Well, good evening from the outskirts of Louisville, Kentucky. My name is Doug Lucas, and I'm here with Emerald Hill Skies. We're happy you're here with us. Tonight we're starting a brand new catalog. I'm kind of excited about this, not going to lie. It's called Cosmic Challenge, and the book is written by Phil Harrington. He's an editor for Astronomy magazine, and wow, when I got to looking into what Phil Harrington has written, I was kind of excited. I'm just going to check our audio and make sure that we're live over here. Yeah, and good to have you here, Mike and Stu. I deserve every little bit of teasing you want to make. Did I remember to charge the microphones? And boy, I'm happy to tell you that tonight I did. We are fully charged on these babies. So, but I do deserve all of the ribbing that you can give me. Stu's remembering last live stream, my mic actually ran out of gas. Stu, you've already also pitched in the super chat, and that's way beyond the call. You said wireless fun. I think you're kind of poking fun again at the wireless mic. But let me tell you, we're a little bit late tonight because my laptop had reinstalled those pesky COM ports over Bluetooth. And I guess Windows must do this when you get pushed to some Microsoft updates, it must reinstall those. And what they don't tell you when you buy an iOptron mount is that if you are connecting to that iOptron mount via, I guess, USB cabling, then when Windows installs those Bluetooth COM ports that are fake and useless to me anyway, it causes the mount not to connect. And boy, for months we had trouble with this, till finally Frank or somebody suggested we try disabling those. Well, they had been reinstalled tonight, so I apologize, we're a little bit late because of that. But I also want to tell you that I think we've got things pretty well going. Here's our RASA telescope. That's a live view of our RASA 11-inch scope out there. If you can imagine, the scope cam is at the base of the scope looking up the mount, up the pier, you know, at the scope. So we're happy about that. The sky is really bright tonight with a very full moon, and you can see that. The observatory is a Pier-Tech 2, it's a Pier-Tech Tele-Station 2 observatory, and like I mentioned, that pier is an adjustable height Pier-Tech 2 pier as well. iOptron CEM70G mount with a Celestron Rowe-Ackermann Schmidt Astrograph, a RASA 11-inch aperture on top of that iOptron mount. And on top of the RASA, we have this little outrigger set up with ZWO ASI2600MC monochrome astrocam. And that's what's giving us our view of the sky. It's about 160-degree wide view of the sky. At the base of that pier are these power distribution boxes, and they come across underground via fiber optic cable, and they're bringing the signal from this ZWO ASI2600MC Pro camera that's at the business end of that RASA 11. And that observatory out there, we're happy to tell you that this past Tuesday, kind of exciting, some friends pitched in and put in a sidewalk. Isn't that beautiful? So now this sidewalk connects the observatory to the rest of the road and sidewalks here at Emerald Hills. So it's just very, very early, no landscaping there yet, but at least that sidewalk is poured, and kind of excited about that. So that's a snapshot I just took moments ago right before coming in. So now let's have a look at what we're seeing here. Let's get in the right mode here. Here is the view through the ASI ZWO ASI2600MC Pro. So our focus is good. We just did a focus in Nina. That looks good. Looks like our tracking is on. It's on. So let's now take a look at this list for a second so that we can get an idea of how this works. The way he has written this is he has he has first of all done a section that is kind of meant for naked eye challenges. And they're like, you know, a number of, I guess, like 21 targets for naked eye. And some of those targets have more than one object in them. Then there's a section for binocular challenges. And the binocular challenges, he's got another, we go up to about 46 or 46 targets for binocular challenge. And then he does another group of objects for giant binoculars or 3 to 5 inch telescopes. And, you know, another 30 or 40 targets for that. Then he does a number of targets for medium scopes, that's 6 inch to 9 1/4 inch by his measure. And then he does a number of targets for large scopes, and he counts that 10 to 14 inch, so our RASA 11 should be in that group. And then he does a group for monster scopes, he calls them, 15 inch and larger, that'd be your big Dobsonians. And all in all, he has, in terms of targets that he lists, you know, those big numbers at the top of the page kind of thing, I guess there would be 188 targets. It ends up with Pluto and its moon, Charon, you know. So it's kind of an exciting list. It's a good mixture of things, like he'll have you do globular clusters and lots of exotic nebulae and open clusters that I've never even heard of us look at before on this channel. Lots of the exotic catalog descriptors that we don't normally use. I mean, I think in this list, when we get done with this, we're going to have a good understanding of like the SMECE list and the IC list, and he does hit some of the more traditional Messier targets and Caldwell targets, but he also goes to things like UKS and Able catalog, the Palomar catalog, several that are not in any catalog. He does ARP objects and sharpless. He uses honestly a ton of the NGC list that we've been going to, but then some of these I'd never heard of. The Junk Air, the J list that stands for Junk Air. I think this is going to give us a really good mixture. Another thing he does, it's not just deep space, and that's really what we've been focusing on. Stop and think about it. Messier list, we did that first. Then we did the Caldwell list. I think we finished all but 3 objects. We finished the Messier list. We did all but 3 objects on the Caldwell list. The Hidden Treasures list and the Deep, Hidden Treasures and, Secret Deep. All 4 of those lists are deep space objects. Whereas Harrington in Cosmic Challenge, he does solar system objects, asteroids, our own planets. So he'll have you observe the giant red spot, the Cassini division of the Saturn's rings, and then later when we get to the monster scopes, there's another division. He has you do features on the moon. I mean, we're literally looking for Apollo landing sites and stuff. I've not done that much in our own solar system because I've mainly, I think you guys on this channel, if you've been kind enough to jump on here with me, we've mainly done deep space, deep sky targets. So this list is going to broaden us. He opens with a good discussion about the eye itself, and he talks about getting dark adaptation and how that works, and the fact that it takes 10 or 15 minutes. He talks about, you know, what kind of scope you have and what kind of viewfinders you should use based on the kind of scope you have. He is, you know, assuming, because it was written some time ago, that you're going to be using eyepieces, and that's just a part of life, I think. But he does do some work with filters. He helps you look at those as well. He talks about, seeing and the Pickering seeing scale. So he does, charts on that and helps you analyze your particular light pollution. He gives you a chart to help you figure out what Bortle class you are. And we're Bortle 6 here. So our naked eye limiting magnitude is 5.5. We can't see zodiacal light here. The Milky Way is only visible if it's at the zenith. Clouds anywhere in the sky appear fairly bright. The Andromeda Galaxy is only faintly apparent to the unaided eye. So he gives you ways you can sort of measure that if you don't have a Bortle chart. But we all have a Bortle chart, right? With our clear, what's it called? Clear sky chart that we have. Okay, then he also divides the targets by season. And it just so happens that he starts with spring. So I'm thinking we ought to just dive in and then get going. But before we do that, let me see what you guys are saying over here. Stu, want to make sure we charged our mic. And of course, Mike, good to have you on board. John, good to have you here. You aren't really late. We've been introducing the new list, Azray, good to have you on from Arizona. You guys are awesome. Tiffany and the Shih Tzu, good to have you here. Greetings from California near the James Lick Observatory. Good to have you here as well. Wires are so last century. Stu rubs it in. But these are fiber optic cables. So that I think we get a little bit of a, give us a little slack because we're using fiber optics. Panadero. Este parece como nombre español. Parece. F. Panadero. Por favor, ¿dónde se queda su ubicación de observación con nosotros? Papa Tech, good to have you on board from Florida. Stu, yeah, we did the Messier list in one night. You're right, Stu. I think we only missed M30, and we've observed it at other times. Vito, good to have you here from Pier-Tech. He's the lead engineer and fabricator at Pier-Tech, so he hand-built most of the observatory, probably had some help. Hand-built the pier. It's going well. You did great work, Vito. Don's reminding us, would you please hit the like button? Don, thank you so much. That helps get the channel up in other people's searches. Stu says, good to see the usual suspects back again. Did you hear about the pirate who got addicted to astronomy? He loved eye pieces. That's awesome. Don, let's see. Papa Tech got a launch tonight at 3:30. Nice. Books, good to have you on from Australia. Stu, of course, from Tauranga, New Zealand. Azray setting up his 10-inch Dob for live stacking tonight. Good. I love it when we work together like this, Azray. Sometimes you float to the same targets. Okay, let's get going then. Let's go over to our targeting and observing software. You guys know that we use Deep Sky Planner, and since there was no online copy of Cosmic Challenge, and we even wrote the author. He didn't answer us back. Since there was no online copy, we had to create this list, hand enter it, one object at a time. So we sent it to the developer of Deep Sky Planner and said, hey, can you please post this in the community so that nobody else has to do this again? And she was so kind, she wrote back immediately and said, oh my goodness, Doug, thank you so much for pitching in. We don't get very much help in creating these lists. So she was very grateful, she said, and indeed she was going to post that. Now our first target on our list in what you might call Cosmic Challenge 1 is M81. So it's from the Messier list. And we've already connected to our telescope here. Honestly, we already have an observation of this target. But I think for the purposes of this list, as much as possible, we're just going to go through the list as it was written. And that way, if you're new to the channel, you'll see some of those targets that we've already observed. I do want to say that in the new version of Deep Sky Planner, if you're thinking about Deep Sky Planner, she's going to add a new setting that'll be called Observed Since a certain date. And using that setting, once version 9 comes, we're running the latest version, Deep Sky Planner 8. Once she gets that feature built into the program, we would be able to say, you know, first time observed since May 3rd. And it would kind of reset an observation column for us, so we could get the sort of reinforcing feeling of checking something off, you see. But tonight, we're not going to have that kind of warm and fuzzy feeling of checking something, because it's already checked. We've already gone to M81 before. In fact, there are 5 observations that are noted here. But we're going to go ahead and pretend like it's not and go there anyway. So what we do with the way this works, we've already connected our software to the telescope. So we just right-click on it and we say slew to M81. So then we'll pull this out of the way. We'll let you guys see the scope camera so you can watch the scope slew. And this gives you an idea of where the scope is going. You can see it leaning over there toward the east. We know it's east because to the camera's right is toward the east. And now you can see the weights rising up into the west. And looks like it's come to a halt there. So we can use the sky cam. Oh boy, there are a few clouds there. These clouds weren't supposed to come in till maybe around midnight, so they've started arriving early. That might be a little trouble, but this was the best night we could find for this week. We're just going to go with it and see how it goes. We also have a moon that is very strong tonight. I'm looking here, the moon is at 98%, so you might as well say it's a full moon. And that's very bright, but we're going to do what we can do. Now let's go back to our screen view, and the scope has settled. We're still looking at 3-second exposures here, but look at the objects we can see already in our view here. Already a couple of targets here we can see. What we're going to do is we're going to use the ability in the software here, and our software here is called SharpCap, that we're using for letting us all see through the telescope. So you might as well call it, it's like imaging software. But it's not really, in our case, using it to do astrophotography. We're using it to do electronically-assisted astronomy. And plate solving will match the telescope's actual view with the view that we were actually seeing. And we were about a ½ degree off because this is our first slew of the night. So now it's put M81 right in the center of the screen. And at this point, we can also click on the neat little feature that they give us, that SharpCap gives us. It lets us see what are some of the objects in our screen. And you can see it's a little bit off, so we'll turn that back off for a second, because when it does sync, you have to solve again. But that is M81 right here in the middle. What we'll do is we'll put up here in the top M81 in our title, and we'll also change our exposures just as soon as it gives us back. We'll change our exposures to 20 seconds and our gain setting to 100, and then we'll start live stacking. And you know what that is. Live stacking is a feature of SharpCap and some other softwares as well. Softwares like the ASI family of softwares that let you take multiple shorter exposures and combine them together, so you, in a sense, compute a kind of average view of the sky. And it essentially averages out all of the glistening, tingly pixels of light pollution. And it averages forward the sources of light that don't change. Now we're only looking at 40 seconds worth of exposures, but look how we can already see the spiral structure of M81. It sort of makes a big S curve, doesn't it? And you can see the bright core here, and then you can see these outer arms that are already forming up. They're already forming up after just 80 seconds. And look how big this object is compared to some of these exotic targets we've been looking at on the Herschel 400. Oh, that's another list I didn't mention, the Herschel 400. We're on the last parts of the Herschel 400 list as well, and those have been the tiniest galaxies, as you guys know. So this is a treat, isn't it, to see this large galaxy of M81. Let's come over here and see what you guys are saying. Let's see. Papa Tex says, oh, you've got a SpaceX launch tonight. That's what you meant. At 3:30 a.m., another SpaceX launch. Got it. Starlink. Uh, 4.5 hours away. So are you saying they're launching that SpaceX launch from down in New Zealand too? I didn't know they had a base down there. Don says, ooh, M81. Papa Tech's going to watch it, so that has to be at the Cape. Okay, so Stu's starting to give us some facts about M81. I'm going to go over here in the observation panel, and the first thing we have to do is add a new session for the night. This is our first observation. And we're gonna say give us until you know, like 2 a.m., something like that, Eastern time. And we're going to say the moon was at 98%. Another thing we often do is we write, do I have to hit cancel? I wonder if that'll destroy that session I just created, but I had to go see what number session this is. Nope, it kept it. This will be session 118. So now we'll edit this and we'll say session 118. Now let's go back to our observation and let's make sure we pick session 118 now. And we're going to say that M81, also NGC, now I didn't know this, 3031 or Bode's Galaxy. Thanks, Stu. I didn't have that memorized. Is a grand design spiral about 12 million light years away in Ursa Major. Don says he's a bit jealous. Is that because, I don't know why, Don. Maybe because these other guys can see the SpaceX launch more closely, I bet. M81 discovered by Johann Elert Bode on December 31st, 1774. Papa Tech's still talking about the launch. The Falcon Heavy the other night was fantastic. Evening launch made the jellyfish. Huh. Don says a pirate calls it eye to eye. M81 sounds explosive. You're right, it sounds like a big firecracker, doesn't it? In late 2022, astronomers reported that M81 might be the source of that, which is a fast radio burst. I'm going to put this here in late February 2022, suspected of the source of a fast radio burst. Interesting. Ricky, good to have you on from Florida. Getting some lanes defined, Don says. Ricky, where are you in Florida? Papa Tech's asking. If it's not cloudy during the Eta Aquariids, we don't mind trying that, Don. I suspect it will be cloudy based on our next 7 days. Stu says only Rocket Labs launched from New Zealand. SpaceX is happening at Cape Kennedy. Ricky's in Fort Lauderdale. Papa Tech's near Daytona. Bingo, Doug. I would love seeing a live launch. Yep. Ricky, oh wow, not too far from me. Good. Appreciate you guys checking in. We have 15 already. Wow, we are getting some nice trails now. Now I have to wonder if some of these stars are not stars that were recently birthed. Because of the gases here, this must be an active star-forming galaxy. And look how some of these areas, there are a lot more of those teeny tiny pinpoints out there in those trails. Well, that's 6 minutes. Let's call it at that. But one thing we want to do before we leave is glance at the M81 in Phil Harrington's book. He points out that a lot of people ask, what's the most distant object you can see with your naked eye? And he suspects a lot of people probably answer M31. But his reckoning is that M31 is 2.5 million light years away. He says actually you would want to go to something like M33, which is 2.9 million, and maybe you can get that with your naked eye. But then he says, what if you could see this, which is M81? And this is something we'd like to ask everybody to go try to find. Let's go to our planetarium software and let's sync it with what the telescope is seeing and then zoom in. So there's M81. Now let's zoom out and get some, by the way, that's the Cigar Galaxy that's close by, which is M82. So they're kind of close beside each other, aren't they? There's a satellite going through our frame. It's a Starlink 2013. We could probably see that if we go to the SkyCam. Anybody see a live satellite there? 2013, Starlink. Anyway, let's get a context for where this is. This is the meridian. So we'll be looking just a little left of the meridian, the imaginary dividing line that traces its way from the north point of the compass up through the celestial pole, the north celestial pole, and up through the zenith. That's this Z. So we're looking halfway up to the zenith. And if you want to find the Little Dipper, the pointer stars of the little bowl of the Little Dipper would almost point at M81 perfectly. And the Big Dipper would be dumping water tonight. It would be upside down dumping water on M81. So I hope you'll try to see this. If you're in a dark sky location, it would be fun if you could try to see this. Now in our same frame, we might see NGC 3077 and also M82. So let's go back over and let's, boy, that's a beautiful shot, isn't it? That's 9 minutes now. Let's back out some. So there's M82. What a beautiful galaxy that is. Look at all those unique color patterns there. Fascinating. And we might also see, depending on where they're got in the frame, I don't see the NGC object. Do you? It must be just off frame up here. All right. So we're going to Rocket Lab also launches from Virginia. These guys are talking about launch sites. All right. Let's stop our live stacking and let's do our, well, let's go over and look at the, yeah, we can go to our, we probably don't need, oh, let's do next target anyway. So we have this sequence, and the advantage of that is it automates some things. So the next object is Melotte, M-E-L-O-T-T-E 111. Lot 111. And let's slew to that. Now, I don't know if you're new to the channel or not, but whether you're new or not, you might be asking, do we just see Messier objects with the naked eye? Well, what Phil Harrington, did I say Dan Harrington a while ago? It's Phil Harrington. What Phil Harrington is trying to help us understand is you can see more than Messier objects. And with your naked eye, you should be able to see Lot 111. And I'm just going to type that in our title on the screen because we might not be familiar with that spelling. Lot 111, it's an open cluster in Coma Berenices. And you can see we're pretty close to the moonlight, but I'm hoping we'll still be able to see this object. We're going to say the mount has settled, and while it's taking care of its business, let's get an idea of where we are in the sky now. So there's the zenith. We're almost straight up in the sky and pretty close to the meridian, maybe just west of it, or is this east of it? Wow, if so, we're going to hit the meridian soon. So it's called the Coma Berenices cluster. Now, if you're noticing the movement of the little RASA crosshairs, what you saw there was the scope doing an automatic plate solve. That plate solve is automatically programmed in this sequence. So now let's go back over to our screen and see if it has already plate solved, if Lot 111 is in here. And it automatically clears the live stacking. We probably won't have to live stack very long in this object. The Coma star cluster, Lot 111, Colander 256. Just kind of trying to get all of our levels starting here to a starting level. Boy, now this cluster doesn't, is it over here? It should be in the middle, so I guess it's this loose pack of stars. Let's take a look here. Yeah, there's that diamond. So he calls attention to this diamond here. And then he comes over here. And yeah, it's very loose. I mean, it's so loose that there really is no gathering by our scope. But if you were outside and you looked at this with your naked eye, these stars would be close enough together. He writes, if seeing M81 by eye alone was too tough of a challenge, here's an easier target that's visible under less demanding conditions. And notice where this is. Coma Berenices is just this simple little triangle here. So if you're going to look for, I guess if we're south of the zenith. So here's the Little Dipper. I guess if you're looking toward the south of the sky tonight, imagine Virgo. If you're familiar with the constellation Virgo here, it's kind of got this little keystone thing in the middle. and tonight the moon is right in the middle of it. Here are Virgo's arms, and it's like she's getting ready to catch this as it falls down. And here's Leo, the lion. The Coma Berenices cluster would be off of the tail of the lion. If you're familiar with Boötes, the kite, it would be just between the tail of the lion, this big question mark. There's a good place to find it. Look for this big question mark, and then this kite of Boötes, and then it would be right in between. So let's go over to our, oh my goodness, that is an absolute mess, isn't it? And I also need to focus. There's so much moonlight there, I don't think we're going to be able to use the sky cam at all. But I do need to focus the sky cam. It has a mechanical focus on the front of the camera, so you can't focus it remotely. So I have to do that from out in the observatory. I've set the laptop out there and hook up the sky cam through an alternative set of cables I have. It's a terrible life, I know. So here's this loose cluster, I guess, right? It's a big cluster, isn't it? Is it this entire thing? Boy, it must take up a lot of space. How wide is it? It's 2 full degrees wide, so it's huge. So maybe this entire thing in our screen is considered the cluster. And Malat 111, let's call up our observation. Is, Stu says, 280 light years away. Don says that's a day trip for sure. Used to represent the tail of Leo. But by 240 BC, Ptolemy, should have told me so, the third renamed it for the Egyptian queen Berenice's legendary sacrifice of her hair. Wow. Papa Tech says I'll have to look it up. You guys are actually talking about a different place, I think. 40 brighter stars. There are quite a bit of different colored stars there. Several orange, many white. So this coma cluster is one that you could find with your naked eye, and I hope you're able to do that someday. Let's go to the next target. And I think we're just going to say, let's go ahead and do the default next target in, just so it'll get plate solving in its model. The next target is actually Alcor. So let's put in the name here, Alcor. Now, why would they have us go to Alcor? I think the reason why he'll have us go there is because I believe he's going to have us look at it as a double star. So now we're in Ursa Major. Looks like it's settled. And the trick is, can you observe Alcor and see that it's a double star with your naked eye. And right away, if you come back here to the screen, you can see that our RASA is indeed resolving this double star. Is it cheating to use an 11-inch telescope? This is Alcor and Mizar. And remember, you've probably heard this before, the Native Americans used to use this as a test of vision. And he goes about the history of all the people who did that and what they called it. Some people have called it the horse and rider, and that's the meaning of the Arabic words Mizar and Alcor. Mizar is the brighter, so Mizar would be this bigger star here. And Alcor is the lesser, the little starry horseman. So this would be a great target for you to try to locate naked eye next time you're out. So how do you know which one to look for? Well, let's go find it on the planetarium software. What we're looking for is the second star in the handle. And again, we're in the Big Dipper, not the small one. So look for the bigger of the two dippers. And remember, the pointer stars point toward the North Star, Polaris, which is the beginning of the handle of the Little Dipper. In the Big Dipper, how can we remember this? It's the second star in the handle. So not the end of the handle, but close to it. And the trick is, are you able to resolve these with your naked eye? And if you are, then you have pretty good vision. And what Stu is saying is that Alcor was discovered to have a companion star, Alcor B, which is magnitude 8.8 red dwarf. And I wonder if this is it. Or maybe not. These are not named in Stellarium. Mizar and Alcor. Oh my goodness, this is like burning a hole through our camera. Let's see if we can get rid of some of that. Let's reset this and reset that and back off this. It is so bright. Look at those diffraction spikes. The RASA has unique diffraction spikes, and I try to lay my cable in such a way that it minimizes them. But really it just sort of balances them out. Okay, I'm going to go over here in the observation. I'm going to say Mizar and Alcor, horse and rider, horse and rider. Alcor is itself also a binary. Alcor B, 8.8 mag red dwarf. Alcorception. It's Alcor is all the way down. Mizar is a brighter one, Alcor is a fainter, with an even fainter companion star. So let's So who knows? Maybe one of these would be Alcor's companion. There's a faint one there. This looks more like magnitude 8.8, but it could also be this. How can we learn this? See if he's got a drawing close up. He does not. And whether or not you can resolve this, it'll it'll basically show you your vision. He doesn't go so far as to try to predict, but he does tell you about how many arc minutes you might be able to resolve. And he does a little test using wide index cards and putting them at different distances. So that's interesting. Horse and rider. Something to try out in the backyard. All right. Our next target is, so both Alcor and Mizar, let's say there's an M3. M3 and let's slew to it. Slew is another word for move. Azray says, I'm trying a new trick tonight. I put my cell phone on the scope and use it to find objects. Well, that is interesting. Alcor B was only 1 arc second away from Alcor A. So it definitely would have been those ones that were farther out. Huh, Stu. Wow, this is a nice little cluster here. Look. That's beautiful, isn't it? I wonder if we have... Wow, that's beautiful. This is M3. Gonna show chart first, and then open up the observation. Because once you open up the observation, you can no longer show chart. And what show chart means is just synchronize it with the telescope. Why didn't it work? It didn't show chart, did it? Show chart. There we go. So M3 is in between, again, Boötes and Leo, but it's closer to Boötes this time. So only about 1/4 of the distance between this ice cream cone cluster, not cluster, ice cream cone constellation and the backward question mark of the front of Leo. Maybe 1/5 of the way, in fact. Beautiful little open cluster. Wow, that's lovely, isn't it? Messier 3 is a globular. Oh, I've been saying open, haven't I? But globular is correct. Sorry, I've been saying open. My mistake. I'm going to back these off so we catch that light, the color of this. It's a unique color, isn't it? Of course, color is all relative based on the chemicals, but bright globular cluster and Canis Venatici, Stu says. Thanks, Stu. Discovered by Messier himself. He mistook it for a nebula without stars. Oh, you're still in SleuCam. Thanks for telling me. It's a beautiful little cluster. Don pretended like he was on the Starship Enterprise. He said, "Computer, enhance." That's awesome. It's beautiful, all right. After we enhanced it. You guys are so patient with me. So that's 100%. Look at it, it's kind of got like a yellowish greenish tinge, doesn't it? At least by the standard color balance that SharpCap does. All the peaks of colors are indeed aligned, so this would lead you to believe that it does have a greenish, yellowish tinge. Patrick Stewart voice. Well, that's what we figured, Don. It's very kind of you to say thanks for the amazing views of the night sky, you say, and to say you appreciate the clarity of both explanation of both the target and what is done in EAA to observe such targets. You are very kind. Thanks for the encouragement. That's very kind of you. Don says, oh, I'm patient, all right. Well, this is beautiful. M3, and let's see what Harrington says. Just south of the Great Bear and Ursa Major. So here's the Great Bear, and we're south of it, see? Talks about it being named after the hunting dogs. Might be one of the sky's dimmest constellations, but M3 is one of the sky's brightest globular clusters. So bright, magnitude 6, M3 can be glimpsed with the naked eye as long as you have a moderately dark sight. So he asks, can you see it? And then he tells you how to find it. He says you got to have dark skies. Excuse me. But he does say that with binoculars, it's a gorgeous target, and I bet it is. Well, 3 minutes is plenty for this object, isn't it? Off to our next target, which is a single star. You're going to know this one, Polaris. And, you know, obviously the way Harrington's doing this, he picks targets that are both interesting but also educational. And he's trying to get the typical naked eye starter astronomer to find Polaris in the night sky. And that way you'll never be lost. And also, it comes in handy for finding the rest of the sky, because from here you can go to the Little Dipper, you can branch out to the Big Dipper. So it's kind of a fundamental landmark to finding so much. If I remember right, Polaris is a double also, right? He says it's a challenge for many people to see the Little Dipper, but it is circumpolar, so you can see it all year. He says it might not be naked eye for you to see the Little Dipper itself, but you ought to be able to see Polaris if you pull it out separately. It says it's better to try to find Polaris when Ursa Minor is highest. I don't know if that makes that much difference for us. And talks a little bit about light pollution in this entry. And rightfully so, light pollution has indeed stolen much of the night sky from us, sadly. Pretty mean diffraction spikes. Polaris doesn't really have any kind of outer layer. This almost looks like something you'd see on a planetary nebula. There's no outer layer. This is just an artifact. It's just an artifact of viewing Polaris through a Newtonian or a Schmidt Cassegrain, or a Rowe-Ackermann Schmidt Astrograph. You're going to get these kind of weird diffraction spikes, and indeed this entire halo just looks like it's kind of drunk, doesn't it? But you just get used to saying, oh yeah, that's what a brighter star looks like. And Stu says, rightfully so in an observation, he's also pointing out that it lies less than 1 degree from true north celestial pole. It's a triple star system, Stu says. A triple star system. Imagine being a rooster, Don says, on a planet in a trinary star system. Don's, of course, poking fun at the fact the rooster would have to crow about 3 different times because the stars would all raise 3 different times. Can I ask, what is a recent target that you observed that you highly recommend us to try with a similar setup like yours? Boy, I don't know. There are so many. Definitely, if you haven't gone to our first target, which was M81, that would be a nice target to start with, M81. It was really beautiful. That would be suitable. Polaris is also named, it goes under the name of Hipparchus 11767. Tiffany and a Shih Tzu giggled, said, yes, Don, that would be a confused rooster. Then Don starts talking about roosters. My sister had them, and in summer they start around 4:30 a.m. Ooh, that's early. Okay, so one more time we're just going to look and see where Polaris is here. And you can see that Polaris is our ticket to find the north celestial pole. And all of these stars appear to be revolving in orbit around that north celestial pole. But we now know that all of these stars are as if close-pinned to the inside of a giant orb that's rotating toward the west always. But Polaris is the pivot point of that orb. It's where your 2 fingers are as you spin the globe or spin the basketball. So look for it about what? 35, depending on where you live, to 40 degrees up in the sky. And if you're on the southern hemisphere, people like Don and Stu, I'm told you guys don't really have a brighter star like Polaris that's situated close enough to be able to call it a pole star. And so your polar alignment with your telescope is a little bit tougher because you don't have a good starting point, I'm told. All right, let's go to the next target. And that would be M13. M13, also a globular cluster in the Hercules constellation. Remember, M13 is that great Hercules globular cluster that is so famous, M13. It's probably the biggest object in the northern sky, right? Glad you like M81. Folks is saying, tell me about it. Oh, tell me about it, you're saying. The octans can be hard to see from metropolitan areas. Gotcha. Yeah, that's southern sky. We need to get you guys broadcasting so we can learn a little bit of your sky. So what we're going to be looking at here is a giant globular cluster, the largest globular to our apparent field of view. Obviously there might be larger globs somewhere, but from the Earth this one appears to be bigger. It's called, you know, the Great Hercules Globular Cluster, for example. He writes a lot about the history, Harrington does. Says that Halley was the first to note M13's naked eye visibility. When he recorded, this is but a little patch, but it shows itself to the naked eye when the sky is serene and the moon is absent. Okay. So that's M13. I don't feel like we have a good view of it yet because we're still in the middle of plate solving here. Don says he lives in the southern hemisphere, but he can still see Polaris if the clouds were gone. Well, that's wild. Ricky says you can see the Omega Centauri from down here. It's beautiful. With Don, that is odd, I'll have to admit. Why is this taking so long to plate solve, pray tell? You think it's because we're into the cluster of stars and it's having a hard time with all the zillions of stars in the picture. Oh, it says sequence halted due to error. Oh, I wonder what the error was. Maybe it couldn't lock onto So what we're going to use is just use the planetarium software to slew to this globular, and it's thinking it's pretty close. It seems to be, once again, trying to solve the frame here for plate solving. I wonder if we came to the wrong part of the sky. There's the great keystone of Hercules. We're looking at east-northeast. This looks right, doesn't it? And it shows, in fact, the RASA is on the target. This red rectangle is the field of view of the RASA, roughly. Too many stars, that's what it is. Too many stars. So what let's do is let's just get something close by and plate solve on it. NGC 6207, for instance, or really any of these stars would work. The wonder of plate solving is when we issue the slew command, Robin Glover has SharpCap set up to listen for that slew command. So when we start plate solving, we don't have to give SharpCap any information because it has heard the slew command to the mount. And it knows what you wanted to try to go see. So what it will do is store that slew command away for such a time as this until it needs it. In this case, we just told it to watch this part of the sky and, you know, try to synchronize to it. Oh, it still didn't sync. So it's saying you could reduce exposure. I don't think we have Hercules in the frame yet. So why don't we go ahead and slew back up to the place where we think Hercules is. And let's slow the time exposure to like half a second. And that'll make fewer stars. Maybe 1 second. Now let's try to plate solve again and see if it can pick those out. How about that, guys? Ricky says you can see Omega Centauri from down here. It's beautiful. Book says I've just got a dew shield for his 8-inch Schmidt Cassegrain. Now it gives him 4 to 5 hours of imaging rather than half an hour before fogging up. Also allows you to do remote imaging and live stacking. Good. Don, why did I think you live somewhere else? It's Books that lives in Australia. Don in Idaho. The moon might be. But look, we can see stars, so you'd think if we can see stars, it ought to be able to see stars. There went an airplane. The amazing thing is if we walk outside on any clear night, we can find M13 with our naked eye. But looking at the lens, looking at the sky through the soda straw of this RASA, let's go over to the sky cam and see what the sky cam is seeing. It is a horrible, horrible picture, isn't it? So you can make out the Big Dipper here. And there's the tail. And we're below that. And trying to see the keystone of the constellation Hercules. Maybe it's right here. So we could just walk outside and see it. I'll tell you what, let's do. Let's go find a really bright star. And let's see how we do with it. Stu's back. Books, for once in Melbourne, we have 5 days of rain scheduled over the brightest moon phase. Normally we have moon or clouds. Now let's plate solve this. So I like this list if you're watching live or if you're watching the recording. (23, 48, 29). Plate solve failed due to 11:48 p.m. No solution found. That's strange, isn't it? The moon's clear up here. So the moon shouldn't be giving us any trouble. That's 60 degrees away. So I don't think it's the moon. Something else. What do you guys think? There is this little thing here. I've never used it, but we could try it. It does a spiral search. I don't even know how it works. We're at full frame. Let's try the plate solve one more time. If that doesn't work, we'll just do that spiral search. Azray, do you know how that spiral search works? Just so you know, the phone app works to find an object. Yeah, exactly. Yeah, we could go outside and take our webcam out, couldn't we? You know what else we could do? I have an idea. Let's go up here under Settings, and let's try changing the app to Astro Tortilla. Sounds like something that would make you hungry. Plate solve failed. 514 stars found. Maybe too many? Try reducing exposure again. 2 seconds. And now we're going to try to plate solve with Astro Tortilla instead of ASTAP. Azray says, I think it spirals out from the center point it points to. Yeah, I just wondered, how does it move? I wonder what the commands are, how it moves, you know. Astro Tortilla is still working. It went to a different index. So what Astro Tortilla is trying to do is look at a different set of plates or images. Do you think M13 is in this frame somewhere and we just can't see it? And that's giving us, yeah, Astro Tortilla didn't, 725 stars it found. Well, this is a little bit of a hassle, isn't it? Let's go back to ASTAP, because I think ASTAP is a better solution for me. And let's drop to 1 second and try again. So you think it just pauses until we tell it to sort of move in the next spiral direction? Because I don't know how. It still failed. Okay, let's try it. Here we go. Let's set it back on 3 seconds again. And we're going to try clicking spiral search. Unless you think it's somewhere in the frame there. I don't see it. I think it'll show up. So what's it going to do now? Hasn't moved in it yet. It doesn't appear to be moving to me. It is definitely in somewhere in the frame I see. Are we supposed to be on the sky cam? Oh, I see what you mean. Sorry, guys. I don't see it in this frame. Don, that was hilarious. I don't think it's here. Shall we go to a different part of the sky, guys? This is taking too long. Let's just go to a different part of the sky altogether. For a moment, let's skip to the next object. How about that? Let's go to M35. Yeah, we're going to go to a different part of the sky. Sorry, that's right. I couldn't find anything. It's such a soda straw to look through the... This is only 20 degrees up. It's pretty low, isn't it? Uh-oh, we're down in the trees. We're not going to be able to do that one. Maybe M82? Let's go to M82. Is M82 the one with the spur? The relativistic jet? Or is that M87? Oh, this succeeded. So there's nothing wrong with our plate solving. It was just that frame was seeing too many stars. But wow, it was offset by 8 degrees. Oh, M82, that's where we were looking a while ago. Now we're going to go back to M13. M82. Ricky, you think M82 is the one with the relativistic jet? Because that's interesting to see that jet spur sticking out about 5,000 light years. I think it's just the principle thing now. I'm determined to get to the Hercules cluster. Can you guys hear the background music? Is it playing softly in the background? Because the way I have this set up, I don't have it playing for me. Just because it doesn't do me any good. It just makes me have to feel like I have to talk over the top of it. Azray, you're right. At 1200 millimeters, it's even harder. Here we go. Now we're talking. Okay, so this is M13. It's a huge cluster, and it is naked eye visibility. It's right in that section of that Hercules keystone. Had you guys already written something about M13 a while ago? Or because we didn't find it, did you not write about it yet? I think it's the latter. Yeah, I don't think we've had any discussion on M13 yet. Okay, good. I'm glad the music's okay. What do you guys think of this? Is it beautiful? It is, isn't it? Look, the temperature's dropped a little bit. You can tell because the stars have gotten a little bit out of focus, haven't they? M13, Harrington writes, it shines at a magnitude of 5.8, so that's on the edge of naked eye. A swarm of more than 100,000 stars. No wonder it was having trouble plate stopping, right? A faint speck, barely visible to the good eye. And Harrington says, trying to spot M13 by naked eye is one of his standard litmus tests for checking the darkness of a summer sky. Pretty interesting. All right. Now this next object that he's got, number 7, I don't think we're going to be able to see it. It's the Great Dark Horse Nebula. And with a full moon, I don't think we're going to be able to see it. But let's go try it just to say we did. Let's go with Great Dark Horse. I don't think this is going to be in here, is it? Dark Horse Nebula. Oh, this might be too low. Yeah, I think it is. So we're going to skip 7. And head for, I wonder if NGC 7000 is in view. Doesn't look like it. M84. Boy, we were just there the other night. Markarian's chain, weren't we? Messier 13, discovered by Edmund Halley, 1714. Cataloged by Charles Messier, June 1st, 1764. 145 light years diameter. Several 100,000 stars. Wow. That's a lot of stars. I'm just going to add that. Several 100,000 stars. 300,000 to 500,000 mil. With estimates varying from 300,000. Oh, that's the number of stars. I see. 145 light years in diameter. Poor rooster. What was the exposure setting for the plate solver? It worked. It found at that time, I believe. Make sure the plate solver knows the correct focal length. Yes, it does. Okay, so we did M81, Malott 111, Alcor Mizar, M3 Polaris, M13. Let's go to M82. So that's where we had gone to a while ago, but I was determined by principle to see M13. M82, so for the sake of orientation, M82 is north-northwest. And remember the Little Dipper points right at it. And remember M82 is where we saw this Bode's galaxy, and this was the other one, the really colorful one. And it does look like it has that relativistic jet, doesn't it? This jet shooting out from it. How interesting is that? So the plasma is excited enough that it sprays it out gravitationally toward the pole of the galaxy, and does that at a distance of about 5,000 light years, and that's far enough that we can pick it up in even an 11-inch scope. So I think it's really interesting to be able to see that. Messier 82 is a starburst galaxy approximately 12 million light years away. Constellation Ursa Major. There she blows. In 2014, in studying M82, scientists discovered the brightest pulsar yet known, designated M82X2. And I wonder if that pulsar is related to the relativistic jet. If this is the one. Is it M82 or M87? I can't remember. Oh, it's not this one? Bummer. Look at the odd coloring on this galaxy. See this patch of orange here toward the core, and then look at this black, what would that be, a dust lane that seems to like bisect it? Where is his M82? I've lost it. M82 7980. He says, this is a tough binocular object. Doesn't talk much about the nature of it being bisected by that funny dark lane that's, in this case, vertical, huh? That's M87, as Ray says. Gotcha. Tiffany and the Shih Tzu. That's just beautiful. It really is unique, isn't it? It's like no other, you know, it just looks like it's been bothered, and quite possibly would it have been bothered by some kind of gravitational dogfight with, you know, M81. Maybe they interacted at one time, but it sure left this one with a weird look, didn't it? Weird bisecting line that's perpendicular to the disk. Curtis, good to have you aboard. Well, let's save this a scene at 3 minutes and head to the next object. We were just at M84 the other night, Markarian's chain. I'm thinking that's so recent. M84 was March 15th. That's a little bit longer than what I thought. Okay, let's head over there. Slewing to M84. M82 is being physically affected by its larger neighbor, the spiral M81. Tidal forces caused by gravity have deformed M82 and caused star formation to increase tenfold compared to normal galaxies. Yeah, that's that starburst effect, isn't it? M84, also known as NGC 4374, is a giant elliptical or lenticular in the constellation Virgo. Charles Messier discovered it in 1781. So that's M84. And as you can see, there's several amazing galaxies here close by. Seconds, 100 gain, live stack. Clear the live stack from the last image. M84. Giant elliptical or lenticular. There we go. So let's see. Several objects in this frame. So this would be M84 here, huh? All right, so we're going to have to clear. Oh no, we didn't mess up anything. You notice the galaxies are lenticular like this. They really don't seem to have a set of arms, do they? It's like they've given up all their arms. There's no commentary on any kind of military symbolism. But these lenticulars just look like, it looks like the Milky Way with no spirals. And somebody said the other day that lenticulars were the most like the loudest source for radio astronomy. All the quasars and all that kind of stuff. And I didn't know this. Apparently, if you've got a lot of radio astronomy, then you tend to be a lenticular. I didn't know that. So there's M84 right in the middle. This is a double star here. Here's M86. Quite a bit, huh, going on in that frame. Well, my phone just went overboard, but I'm not going to worry about it now. I'd rather talk to you guys than talk on my phone right now. M84. No reason to think that they're tidally matched in this case. Very little interstellar matter, made up of mostly old stars. Dust is generally found only near the galactic core. Boy, there's a lot going on in this frame. Lenticular galaxies are disk galaxies that have used up or lost most of the interstellar matter, therefore have very little ongoing star formation. Just look like little headlights in the fog, right? Headlights in the fog. That is what we are. Okay, well, let's stop the live stack. Let's go to next target and go to M104. You guys might recognize that number, right? Yeah, that's one, for some reason, that one sticks in my head. M104. Can anybody call it out? Yeah, I think you're right, Don. I think there were at least 4 there, if not more. Anybody remember what M104 is yet? For some reason, this one sticks in my mind, the Sombrero Galaxy. One of the most photogenic galaxies in the entire sky. M104. Sombrero Galaxy, Stu says, also known as Messy Object 104, M104, NGC 4594 is a peculiar galaxy of unclear classification in the constellation borders of Virgo and Corvus. A tip of the hat to it. Yeah, that's right. So for orientation, we're looking toward the west-south, or the south-southwest. Very close to the moon in this case. Let's see how close we are. Only 12 degrees. Okay, this is going to be a test of our EAA. Can we see anything in this frame? 12 degrees from a full moon. Is it even going to work? Oh my goodness, it's floodlit. It is an odd galaxy. Now in this case, the way the telescope is oriented, yeah, see how it's kind of over on its side. So the Sombrero Galaxy is going to be on its side instead of flat. So you got to kind of tilt your head. I just think it's so interesting. It almost looks like, to me, that we're being invaded by a UFO. This could be the flying saucer from Lost in Space. Yeah, I can't understand how we're seeing anything, just 12 degrees from the moon. Nice lens flare, yeah. 31 million light years from the Milky Way galaxy. Peculiar galaxy. We should call it the flying saucer. The flying saucer galaxy would be a name that would work for this one. Mars attacks. Forbidden planet, Don says. The day the Earth stood still. Right. Three minutes. Kid stuff for the full moon. Why should people ever stop observing around full moon time? See, I think it's the principle of the thing should keep us going. $49,000 light years across. M31 is 152,000. So Andromeda Galaxy is bigger. Independence Day, that's the one we were thinking of. Let's come back out here to the web. Independence Day, flying saucer. Independence Day movie, flying saucer. Trying to find the best view of it. Probably that one. So this is the Sombrero Galaxy, M104. As you can see, here's another live view of it. Only in this case, it's heading for Earth, covering a vast amount of space in mere nanoseconds. All right, so we're going to save this to prove that we saw it on a moonlit night. And that's probably it, gang. You know, we've enjoyed this tonight. We got started on this new list, the Cosmic Challenge, listing more than 500 sky targets, both near and far, and 187 challenges. This observing guide will test novice astronomers and advanced veterans alike. Its unique mix of solar system and deep sky targets will have observers hunting for the Apollo lunar landing sites, searching for satellites orbiting the outermost planets, and exploring hundreds of star clusters, nebulae, distant galaxies, and quasars. We hope you'll come back to Emerald Hill Skies. Thanks to Stu, who pitched in that special gift for that super chat. If you want to know more about Emerald Hill Skies, you can go to the website emeraldhillskies.com, where you will find in the resources page a list of all the different catalogs we're pursuing, along with our progress toward them. We'll update the Cosmic Challenge list because we just got it filled in there recently the other day. There's also an EAA 101 section. In fact, you can even type EAA101.com from any computer in the world. Just type in EAA101.com and it'll take you to the knowledge base that we're trying to assemble there on EAA. And don't forget that tonight we were able to celebrate the new sidewalk at Emerald Hills Skies. Woohoo! So celebrate that with us. And thanks to God for providing everything that He does, all these cool objects, and all of you as great friends. Thank you all. You say kind things. Tiffany and the Shih Tzu, you're saying eternal gratitude for such a lovely evening. So kind. Ricky says, where are those shirts? The easiest thing to do is to go to the YouTube site, and you can get to that by saying youtube.com/@EmeraldHillSkies. So youtube.com/@Emerald Hill Skies. That's one way you can get to the channel. Once you get there, there's a link in the menu that actually says Store. And then from there, you can click on any of the spread shop links. Like for this, women's t-shirt or this men's t-shirt, you can go there and it'll show you the shirt. And then once you're here, it lets you search for anything. Hoodies, you get any color. I mean, there are tons of them. And it's a little bit more complicated to go there directly because it's emerald-hills-skies.myspreadshop.com. So there's an Australia version. So if you're ordering from Australia, books, you can actually go to the Australian version, and they're beautiful. All these different, you can do anything. You can buy organic products. Thanks for asking that, Ricky. We'll have to remember to send you a special thanks for being that guy who asked that. Azray, good night. Good luck with your observing. Mike Jerry, thank you for being on board. Very kind of you to be here, brother. Don, good session. It was a good new list, wasn't it, Don? This will be a fun list. All right, that's it from Emerald Hill Skies, guys. Thanks so much for being here. I look forward to seeing you next time. And keep looking up. Keep that hope strong, and we'll see you on the next clear night. God bless and good night.